Bonjour and welcome back to Midha Guru. It's me, Manan, the math faculty here. And today we are going to take on a very interesting unit of mathematics known as trigonometry. Do you know what it is? If you don't, do not worry. In today's lesson, we are going to cover the basics of trigonometry and how we arrive at all the trigonometric ratios. And also, we'll cover the trigonometric ratios of some specific angles that we see in almost every trigonometry problem. For example, 0 degrees, 30 degrees, 45 and so on. Are you ready? Let's get into the lesson. Imagine you are in an episode of Kaun Banega Karodpati and this is the multi-million dollar question. What are trigonometric ratios? Or more generally, what is trigonometry itself? Well, it is a branch of mathematics that deals with the relation between angles and the sides of a specific type of triangle, that is, right triangles. We know that a right triangle is one that has one right angle. We can see that the triangle is right angled at this particular vertex. If we name this triangle as triangle ABC, we know that apart from the right angle, it will have two other angles as well. Let's just name them angle C and angle A. And the process that we are going to use to understand what trigonometric ratios are, we'll take angle C as our reference. Well, trigonometric ratios are ratios between the different sides of a triangle based on the reference angle. How do we calculate them? Well, before that, we need to know the names of said trigonometric ratios, right? The first is known as the sine, and we write it in the way the name of the trigonometric ratio followed by the name of the reference angle. Here we have sine C because C is our reference angle. The next trigonometric ratio is known as the cosine, or we write it as cos. The third is the tangent, which we write as tan. The fourth is known as the cosecant, which we write as cosec. The fifth is the secant, which we refer to as sec. And the last is the cotangent, which we refer to as cot. All these ratios that we just named, as you can see on the board, they are with reference to this particular angle C. Well, before we go about the values of said ratios, let's just name the sides of the triangle. In a right triangle, we know that the side opposite to the right angle is known as the hypotenuse. We'll just leave that as H. As the reference angle is C, we know that the side opposite to this angle C would be called the perpendicular, and the side adjacent to it, that is the side that the triangle is resting on, is known as the base. Now, these trigonometric ratios of said angle are ratios between any of the two of these three sides. Which two? Well, we can get the sine of said angle by the perpendicular divided by the hypotenuse. That is the ratio between the perpendicular and the hypotenuse of said triangle. The cosine can be given by the base with respect to the hypotenuse. The tangent can be given by the perpendicular divided by the base of the triangle. Cosecant can be written as hypotenuse divided by the perpendicular. The next trigonometric ratio, that is the secant, can be given by the hypotenuse divided by the base. And the last, that is the cotangent, can be given by the ratio of the base and the perpendicular. These are just how we get to set trigonometric ratios. We'll understand its application in a bit, but what you need to understand is that the reference angle that we consider is of utmost importance. This is because if we were to calculate the trigonometric ratios for, let's say, angle A, the perpendicular and the base would be different, because this triangle could be drawn in this manner. The hypotenuse would remain same, but this said base would become the perpendicular when we reference it to angle A. So this would become P and this would become B. And so the values of set trigonometric ratios would change for angle A. So it does not matter how you draw your triangle, but the matter of importance is knowing which part of the triangle is to be named the perpendicular or the base based on our angle of reference. Okay, so now getting into the trigonometric ratios. So what we just learned about the trigonometric ratios, let's try to understand its application in a bit more depth. Here we are going to calculate set trigonometric ratios with reference to angle C. Now as you can see in this triangle, it is right angled at the vertex B. So this side would be the hypotenuse. As we learned, the side opposite to the said angle can be named as the perpendicular and the side adjacent to it can be named as the base. Let us take some arbitrary values for all three. Let's say the hypotenuse is 15 centimeters, the perpendicular itself is 12 centimeters, and this base here is 9 centimeters. So what would these trigonometric ratios mean? Well, the first, if you can remember, was the sine. The sine of said angle C would be the perpendicular divided by the hypotenuse, right? Here our perpendicular is 12 and hypotenuse is 15. So when we divide 12 by 15, we get 4 by 5. This would be the value of the trigonometric ratio sine for said angle C. Our next trigonometric ratio is the cosine, or what we call as cos. If you can go back to the previous slide, we remember that cos was base divided by the hypotenuse. Our base here is 9 centimeters and the hypotenuse is 15. So the value of the trigonometric ratio cosine for the angle C would be 3 by 5. The next trigonometric ratio, the tangent, which we refer to as tan, as you remember, is the perpendicular divided by the base. Our perpendicular here is 12 and the base is 9. So we get 12 by 9 or 4 by 3. So the value of the trigonometric ratio tangent for said angle C would be 4 by 3. The next is the cosecant or the cosec. The value of the cosecant with respect to C would be the hypotenuse divided by the perpendicular. The hypotenuse being 15 and the perpendicular being 12, we get 15 by 12, which we can write as 5 by 4, right? The next would be the secant, or what we call as sec. The value of the trigonometric ratio sec for said reference angle C would be the hypotenuse by the base, which is 15 by 9, which we get 5 by 3. And the last would be the cotangent, what we refer to as cot. Now the cot for said reference angle C would be the base divided by the perpendicular, which we get as 9 by 12. So the value of this would be 3 by 4. This is how we apply the knowledge of trigonometry to calculate the different trigonometric ratios for said reference angle C, or for that matter for any angle in any right triangle. Now what does all this mean to us? Well, let's say if we have a triangle in which we know that said angle C is of some measure. Let us say it is x degrees, and we know that the hypotenuse of this triangle is, let's say, 20 centimeters. Will I be able to calculate all the other sides? Well, if I were to know the value of any one of these trigonometric ratios, I would be able to. Let us say that the sine of this particular angle C in this right triangle is the same as the last one, which was 4 by 5. We know that the sine with respect to the triangle is the perpendicular divided by the hypotenuse. We don't know the length of the perpendicular, so we'll just name that as P. Now we know the length of the hypotenuse as 20. This should be equal to 4 by 5. So when I divide this, I get that perpendicular is equal to 16 centimeters. Now, we know that the cosine of said angle C was equal to 3 by 5. And we know that with respect to the triangle, the cosine would be the base divided by the hypotenuse. Again, we do not know the base, so we'll just leave that as B. We know the length of the hypotenuse, and if we substitute that here, we get that the base is equal to 3 times 4 or 12 centimeter. So this is how we apply the values or the idea of trigonometry to calculate either sides based on the angle given or the angle based on the sides given. Well, now that we have understood in a bit what trigonometric ratios actually are and what the formulas or ways of calculating them are, let us see what the relation, if any, is there between two or more trigonometric ratios for any specific angle. The sine of any angle theta is given by perpendicular over hypotenuse, and the cos is given by base over hypotenuse. Coming to tan, we get tan by dividing the perpendicular by the base. If I just write this down as p by h and b by h, that is adding h denominator to both the first part and the second part of this fraction, we see it does not make much of a difference as h and h can cancel out. But we know that p by h is sine theta and b by h is cos theta. So now we arrive at the conclusion that tan theta can also be calculated by dividing the sine theta by the cosine of the theta. Next, we come to the cosecant. Cosecant is given by the hypotenuse over perpendicular. If I write this down as 1 by p by h, it means the same thing, right? But we know that p by h is nothing but sine theta. So now we arrive that the cosecant of the theta is equal to the reciprocal of sine theta. In the same way, secant theta can be written as hypotenuse over base, or which we can write as 1 by base over hypotenuse. And we know that base over hypotenuse is nothing but cos theta. So secant theta is the reciprocal of the cosine theta. Now, we come to cot theta. Now cot theta is given by the base divided by the perpendicular, or we can write this as 1 by p over b. We know that p over b is tan theta, so 1 by tan theta should give us the cotangent of theta, which means that the cot of theta is the reciprocal of tan. But that's not it. By what I mean by that is that cot can also be given if you see that cosecant is h by p and secant is h by b. So when I divide the cosecant by the secant, I will get cot theta as well. So these are all the trigonometric ratios and the relations between each of them. Well, as we have learnt quite a bit so far, so we are going to solve the problems that is in the NCERT book marked as exercise 8.1. If you can open that and start with me, we'll try and solve each problem head on. Let's get into it. The first problems, if you can see in your textbook, says that in a triangle ABC, which is right angled at B, AB is equal to 24 centimeters and BC is equal to 7 centimeters. We are supposed to determine the values of the sine of angle A and the cosine of angle A, and so the sine of angle C and the cosine of angle C. As in geometry, to ease our work here, the easiest work to be done is first draw a rough diagram. We know what a rough right triangle looks like, right? So, as the problem suggests, it is right angled at the vertex B. Let's name any angle as A and C. Now, to calculate the value of sine A and cos A first, that is, keeping A as our reference angle. It is also given that AB is 24 centimeters and BC is 7 centimeters. Don't be thrown off by the diagram that I have drawn. If you can imagine that this triangle was drawn in such a way where BC is still 7 centimeters, AB is 24, and this is the right angle, and we are supposed to calculate the values for reference angle A. Now, the first value we need to calculate is the sine of A. If you remember by formula, sine of A would be the perpendicular divided by the hypotenuse. But hold on, we don't know the value of the hypotenuse. But it's quite simple. We know Pythagoras theorem, right? We can calculate the hypotenuse by saying that h square would be equal to p square plus b square, where h, p and b are the hypotenuse, perpendicular and bases respectively. We know that the perpendicular is 7 centimeters, so we write 49, and we know that 24 squared, that is the base of the square, is 576. On adding this, we get 625, and this is the square of the hypotenuse, so hypotenuse would be equal to 25 centimeters. Coming back, now we know that sine by formula is the perpendicular divided by the hypotenuse. So we write that down as 7 by 25. As this cannot be simplified anymore, we leave it as this. So the value of sine for the reference angle A would be 7 by 25. Now, to calculate the value of the cosine of said reference angle A, we know that the cosine can be given by dividing the base by the hypotenuse, that is b by h, which we get 24 by 25. As this cannot be simplified any further either, we leave it at this. So the cosine for said reference angle A in this particular triangle would be 24 divided by 25. Now, it says to find the sine and the cosine of angle C. Coming to this triangle, this is our reference angle C. Now we know that the hypotenuse is 25 centimeters. So, again by formula, sorry for my mistake, the sine of C would be the perpendicular divided by the hypotenuse. Now in this case, as this is the reference angle, this would be the perpendicular side. So the sine of C would be 24 divided by 25. So as we cannot simplify this any further, we come to the conclusion that the trigonometric ratio sine for the reference angle C is 24 divided by 25. To calculate the cosine, we know that the formula is base by hypotenuse. The base here is 7 and the hypotenuse is 25. So we leave it at that as it cannot be simplified any further. So if you have understood better, you would have been able to solve this problem. If not, it's well and good. We still have a lot of time to understand. Moving on to the next question. It says that in the figure, find tan P minus cot R. The figure here is something like this. We have a right triangle PQR, which is right angled at the vertex Q. The length of PQ is 12 and the length of PR is 13. We do not know the base of said right triangle. Before we do anything, let's just find the value of QR. QR in this case would be the base. By Pythagoras, h square is equal to p square plus b square. We know that h is 13, so the square of 13 would be 169. The perpendicular is 12 and the square of 12 is 144. So b square would be equal to 169 minus 144, which we get as 25, which gives us that the base is 5 centimeters. Now coming back to our problem, we need to find the value of the tangent of P minus the cot or the cotangent of R. For the first, let us take P as the reference angle. If you could just look at this triangle sideways, this would be the perpendicular, this would be the base as it is adjacent to the angle P, and the hypotenuse remains unchanged no matter where you look at the triangle from. So now we know that the value of tangent for any angle is the perpendicular divided by the base. In this case, the perpendicular is 5 centimeters and the base is 12 centimeters. So the tangent for P would be 5 divided by 12. Now to calculate the cotangent for angle R. As we change our reference point to angle R, this side of 12 centimeters becomes the perpendicular and QR becomes the base. Now we know that the cotangent can be given by the formula base divided by perpendicular. As I just said, the base is 5 and the perpendicular is 12. We get that the cotangent of R is equal to 5 by 12. And according to the question, we need to find the value of tan P minus cot R. Substituting the values that we just found out, we get 5 by 12 minus 5 by 12, which would be equal to 0. Moving on to the next problem. Up till now, we solved problems in which we are given a triangle in which the different sides were either given to us or we were easily able to calculate them. Here, we are just given any one of the trigonometric ratios and we ourselves are supposed to calculate all the others. So, it says that sine A is equal to 3 by 4. Let's just draw a rough diagram in which, let's say, this triangle ABC is right angled at B and A is the reference angle with respect to which the value of sine A is given. It says that sine A is 3 by 4. We know that sine is calculated by dividing the perpendicular by the hypotenuse. As we do not know the exact values, let's just say that the perpendicular is 3k and the hypotenuse is 4k. Our first step would be to calculate the value of the side AB or the base with reference to angle A. By Pythagoras again, the square of the hypotenuse would give us the sum of the squares of the perpendicular and the base. 16k square would be equal to 9k square plus b square. B square is equal to 7k square, or b is equal to k root 7. So now we know that the value of this side is root 7k. Now we have to calculate the value of cosine with respect to A and tangent of said angle A. So with reference to angle A, the cosine would be the base divided by the hypotenuse. So we write down root 7k divided by 4k. As k is common, we cancel it out and we get the value of said cosine of angle A would be root 7 divided by 4. And also we have to calculate the value of the tangent of A. By formula, we know that tangent of A would be equal to the perpendicular divided by the base, that is 3k divided by root 7k. Again, k being common, we strike it out and we get that the tangent of said reference angle A would be 3 by root 7. Moving on to our next problem. In the next problem, it is given that 15 times of cot A is equal to 8. We are supposed to find sine and the secant. Again, as in the last problem, let's just draw a rough diagram. As you can see, this right angle, the right triangle is right angled at vertex C. It says that 15 times of cot A is equal to 8. So let's first just find the value of cot A. If 15 into cot A is equal to 8, we can write that down as cot A is equal to 8 divided by 15. So now we know the value of the cotangent of said reference angle A. We know that by formula, cotangent would be the base divided by the perpendicular. In this case, this would be the base, that is the side adjacent to A, and the side opposite to A would be the perpendicular. So we just write this down as 8 and this as 15. Our first step would be to calculate the hypotenuse. So, as we already know, h square is equal to p square plus b square. That is, we know perpendicular is 15, so the square of 15 would be 225 and the square of 8 is 64. We get 289. So the hypotenuse square is 289. So the hypotenuse would be equal to 17 centimeters. Sorry for placing the unit. Let's just write that down as 17. So now we know that sine can be given by the formula perpendicular divided by hypotenuse. We know that with reference to angle A, the perpendicular is 15 and the hypotenuse is 70. As this cannot be simplified, we leave this value here. So the sine of angle A would be 15 divided by 17. If you remember, we learned how the trigonometric ratios are related to each other. We know that secant of A is also equal to 1 by cos A. Let's just try that out. Let's try to calculate the value of cos A first and then substitute in this. We know that the cosecant of said angle A is given by the base divided by the hypotenuse. So let's just substitute that value down here. We get 1 by 8 by 17, which can be reciprocaled as 17 by 8. So the value of secant for angle A would be 17 by 8. The next problem in the exercise is that secant theta is equal to 13 by 12, and we are supposed to calculate all the other trigonometric ratios. For this, the easiest way would be to first draw a rough triangle. Let's just say this is the angle theta. Now it says that the secant is equal to 13 by 12. We know that secant is given by hypotenuse divided by the base. So if this would be 13, this would be 12. Again, our first step would be to calculate the length of side BC. We know that h square is equal to p square plus b square, which means that 169 is equal to p square plus 144. We get that p square is equal to 169 minus 144, should be 25. So the perpendicular is equal to 5. Now we can go about calculating all the trigonometric ratios, as we have a rough reference of what all the three sides would measure. So the first trigonometric ratio sine would be the perpendicular divided by the hypotenuse. We will simplify these ratios wherever possible, but where the division is not possible, we'll just leave it as we get it. The next trigonometric ratios is the cosine, which is given by the base divided by the hypotenuse. The next is the tangent. We know that tangent can be given by dividing the perpendicular by the base, that is 5 by 12. The next would be the cosecant, which we can calculate by dividing the hypotenuse by the perpendicular, and we get 13 by 5. The next would be the secant, but we already know that is 13 by 12. And the last would be the cotangent, which we can write by dividing the base by the perpendicular, which you get 12 by 5. So, as you can see, with respect to any one of the trigonometric ratios given to us, we were able to calculate all the other trigonometric ratios. Moving on to the next problem. So in the next problem, if angle A and angle B are acute angles such that the cos of A is equal to cos of B, show that angle A is equal to angle B. Think about this problem in your minds for a minute. What are we supposed to do here? We have two separate angles A and B, which are both acute. The cosine of A is equal to the cosine of B, and we are supposed to show from this relation that angle A is equal to angle B. Let's go about this. We draw a triangle ABC, and from the vertex C we draw a perpendicular. The triangle is such that the cosine of A is equal to the cosine of B. If I name this point as D, what would the cosine of A be? We know that cosine is the base by the hypotenuse. So the base here is AD and AC is the hypotenuse. So cos A would be equal to AD by AC. In the same way, in the triangle CBD, the cosine of B will be equal to the base divided by the hypotenuse, that is BD divided by BC. Now we know from the question that cos A is equal to cos B, which means that AD by AC is equal to BD by BC. If I just interchange these two values, this becomes AD by BD is equal to AC by BC. Let's say this is equal to some constant K. So then AD will be equal to K times of BD and AC will be equal to K times of BC. Let's just leave that for now. Now coming back to the triangles ACD and BCD. As we can see, both are right triangles, so we can apply Pythagoras theorem to both of them. The Pythagoras in this would be such that AC squared is equal to CD squared plus AD squared. So from that we can get that CD squared is equal to AC squared minus AD squared. Now we derived some values for AC and AD. If we just apply that to this equation, we get CD squared is equal to K times BC squared or K squared and K squared BD squared. If we take the K square out common, we get K square BC square minus BD square. Now in the other triangle BCD, by Pythagoras we will get BC squared is equal to DC squared plus DB squared, which means that DC or CD squared would be equal to BC squared minus DB squared. Now we know that CD is the same line for both the triangles, which means that the square of CD will also be equal in both the cases. So K square BC square minus BD square should be equal to BC square minus BD square, as DB and BD are nothing but the same line segment. So as you can see, BC square minus BD square is common on both sides. So when we strike this out, we get that K square is equal to 1, hence K will also be equal to 1. Now if we apply this value to this relation right here, we get that AC is equal to BC, which would mean that this triangle right here ABC is an isosceles. Now in our isosceles triangle, as the two sides are equal, so are the angles opposite to these equal sides. That is, the angle opposite to this side is angle A and the angle opposite to this side angle B, and these both are equal, which proves that angle A is equal to angle B. Let's move on to the next problem. So the next problem says that the cotangent of theta is 7 by 8 and we are supposed to calculate this particular value and the value of the cotangent squared. Well, as in all problems related to trigonometry, let's just draw a reference triangle. Let's just name this angle as theta, or angle A is also known as angle theta. So we know that cot theta is equal to 7 by 8, but we know that by formula cot would be the base divided by the perpendicular. So the base would be 7 and the perpendicular would be 8. So what is the value of side AC, or the hypotenuse of the triangle? Again, by Pythagoras we get that h square is equal to p square plus b square. So the perpendicular is 8, so 64, and the base is 7, so 49. We get so the hypotenuse squared is 113. So the hypotenuse would be root over 113. Let's leave it at that. Now to calculate the value, we need the values of sine theta and cos theta, as they are the only two relations in said problem. So the sine of theta, as we know, is the perpendicular divided by the hypotenuse. So we wrote that down as 8 by root over 113. The value of cos theta is given by the base divided by the hypotenuse. Now we are supposed to calculate the value of 1 plus sine theta into 1 minus sine theta divided by 1 plus cos theta multiplied by 1 minus cos theta. If we apply a bit of algebra, we know that this is 1a plus b into a minus b, and the same down here, which means that we would get 1 minus sine square theta, that is a square minus b square, and the same goes for down under. So, if sine theta is equal to 8 by root over 113, we know that sine square of theta would be squaring this entire value, which would give us 64 by 113. And in the same way, cos squared theta would be equal to 49 by 113. Okay, so now that means 1 minus, we calculated sine square would be 64 by 113 and 1 minus 49 by 113. Which we get 113 minus 64 is 49. 64. As both the 113's get cancelled out, we get that the value of Z would be 49 by 64. To calculate the next value, we already know that the value of cot theta is equal to 7 by 8. So cot squared theta would be equal to 7 square by 8 square, which is 49 by 64. So we calculated both the values that we were supposed to. Moving on to the next problem. In our next problem, that is problem number 8, it is given that 3 cot A is equal to 4. And we are supposed to calculate the value, or we are supposed to check whether 1 minus tan square A divided by 1 plus tan square A is equal to cos square A minus sin square A. Again, let's just draw a reference triangle. It says that 3 times of cot A is equal to 4, which means that cot A is equal to 4 by 3. Now we know by formula that the cotangent is the base divided by the perpendicular. So we write down this as 4, this as 3. To calculate the hypotenuse, we again apply Pythagoras, which gives us that h square is equal to 16 plus 9, that is the base square plus the perpendicular squared. And we get is equal to 25, so h is equal to 5. Now, to calculate the values of tan and cos and sine. First being sine, we get that sine is the perpendicular divided by the hypotenuse. The cosine is the base divided by the hypotenuse. And the tangent, as we earlier learned, can be given by dividing the sine by cos, which would give us 3 by 5 divided by 4 by 5. We can remove both the denominators and we get 3 by 4. So, now we know the value of sine, cos and tan. To check what we are supposed to, first to calculate the squares. So sine squared of A would be 9 by 25. The value of cos square A would be 16 by 25, and the value of tan squared A would be equal to 9 by 16. Now it says 1 minus tan square A by 1 plus tan square A. Let's calculate the left hand side first. So the value of tan squared A is 9 by 16. So 1 minus 9 by 16 divided by 1 plus 9 by 16. This is the LHS, which would give us we get the value that the left hand side is equal to 7 by 25. Now to calculate the value of the right hand side, it says cos square A minus sin square A. We got that cos square A is 16 by 25 and that sin square A is 9 by 25. So 16 by 25 minus 9 by 25. As the denominators are same, we can just subtract them to get 7 by 25. As you can see, the LHS and the RHS are equal. So said condition would be true. It is true as LHS is equal to RHS. Our next problem, problem number 9, has a bit more of complex mathematics involved. So let's just divide it into different parts. First part is to draw a reference triangle and to calculate the reference length, that is not the actual length, but based on said trigonometric ratio, the length of all the sides. So, according to the question, this is a right triangle at angle B. We'll name this as C and this as A, as our reference angle is A. Now, it says that the tan is 1 by root 3. We know the tan can be given by perpendicular divided by the base. So, to calculate the hypotenuse, we apply Pythagoras again. The perpendicular is 1, so 1 squared is 1 and the square of root 3 is 3. So, h square is equal to 4. So, the hypotenuse is 2. We write this down as 2. Now, we are supposed to calculate the value of sin A into cos C plus cos A into sin C. Let's solve that first. Sin A into cos C plus cos A into sin C. So our second part, as you can see, the second part also involves just to calculate cos A into cos C minus sin A into sin C. So let's just calculate the values of sin A, cos A and sin C and cos C separately. So with reference to angle A, sin would be the perpendicular divided by the hypotenuse, and the cos would be the base divided by the hypotenuse. For reference angle C, this would be the perpendicular and the side marked as 1 would be the base. So the sine of angle C is the perpendicular divided by the hypotenuse, and the cos would be the base divided by the hypotenuse. Now, to calculate the value of this, sin A into cos C. Now sin A is 1 by 2 and so is cos C. So 1 by 2 into 1 by 2 plus cos A into sin C. Cos A being root 3 by 2 and sin C is also root 3 by 2. So we get 1 by 4 plus 3 by 4. If we add these both, we get 4 by 4, that is equal to 1. Now moving on to the second part, it says to calculate the value of subtracting sin A into sin C from the product of cos A and cos C. So we know that cos A is root 3 by 2 and cos C is 1 by 2. So root 3 by 2 into 1 by 2 minus sin A is 1 by 2 and sin C is root 3 by 2. As these both are same, we can just strike it out. We get the answer as 0. So, moving on to the next problem. Well, in problem number 10, it is given that a triangle PQR is right angled at Q. The length of PR and QR summed up is 25 cm and the length of PQ is 5 cm. We are supposed to determine the values of sin P, cos P and tan P. So our first step would be to draw the reference triangle and calculate the length of all the sides. So, as the question suggests, the triangle is right angled at vertex Q. Now, it says that PQ is 5 cm and the sum of these two sides is 25 cm. Let us just say that QR is of length x. So the hypotenuse, that is PR, would be 25 minus x. Now to calculate the value of x, let's just apply the Pythagoras theorem that says h square is equal to p square plus b square. The hypotenuse here is nothing but 25 minus x. So 25 minus x whole squared is equal to the perpendicular, that is 5. So 5 squared is 25 and we have here x. So x squared. We get this a minus b whole square is a square plus b square minus 2 times of ab. As x square is present in the positive on both sides, we just cancel it out. And bringing this 25 to this side and taking this minus 50x to the other side, we get 50x is equal to 600. So x would be equal to 600 divided by 50, which is equal to 12 centimeters. So this side QR is 12 centimeters, and so this 25 minus x would be 25 minus 12, which is 13 centimeters. Now, to calculate the value of the trigonometric ratios sine, cos and tan for the reference angle P. Now, as you can see, this is the angle P. So this would become the perpendicular, this would be the base, and this, as you know, is unchanged, the hypotenuse. So the sine of angle P would be the perpendicular divided by the hypotenuse. The cos of angle P would be the base divided by the hypotenuse. Now by relation, we have learned that tan P can be calculated by dividing sine by cos. So 12 by 13 divided by 5 by 13, cancelling out 13, we get the value of tan P is 12 by 5. Moving on to the last problem of your textbook exercise. The last problem from the textbook exercise is a true and false, but we are supposed to justify all our answers. It says that the value of tan A is always less than 1. A justification you could give for this answer is going back to just the last problem that we solved, that is problem number 10. We got the value of tan A somewhere equal to 12 by 5, right? So we can see that in some triangle the value could be more than 1, which means that this statement here is false. For the second, we'll just draw a reference triangle. Let's say this angle is theta. Now it says that secant A is 12 by 5 for some value of angle A. We know that secant is given by the hypotenuse divided by the base. So we just name this as 12 and 5. Can you calculate the side of BC? Is it a real number? Well, it can be calculated, right, by applying the Pythagoras theorem, which means there will exist some triangle for which the value of secant of angle A would be 12 by 5. So this statement is true. The third says that cos A is the abbreviation used for the cosecant of angle A. Without any justification, we just know that this is false, as cos is the abbreviation used for cosine, and the abbreviation for cosecant would be cosec. So we'll mark this as false as well. Now, it says cot A is the product of cot and A. If we are studying algebra, the statement would be true. But here we are in trigonometry. We know that when we write down cot A, cos A, secant A or any other trigonometric ratio, it stands for a function for said reference angle. So this statement is also false. Now coming to the last one, it says that sine theta is equal to 4 by 3. Let's draw another reference triangle. Let's just say this angle is theta. Now we know that sine can be given by the perpendicular divided by the hypotenuse. So we'll mark this as 4 and this as 3. If you can look at this triangle is clearly right angled at this vertex. So this side would be the hypotenuse, right? But by the properties of triangles, particularly the property of right triangles, we know that the hypotenuse is the longest side of any right triangle. So this diagram that we drew denies that definition. So this statement itself would also be false. Well, as we now have come to the end of our exercise, we'll move on to the next topic, that is how to calculate the values of certain specific or very common angles that we'll face in all types of trigonometric problems. Let's move on to that. Coming to the next topic, we are going to see what the different values of the trigonometric ratios of some specific or common angles are, and I'll teach you a very easy way how you can calculate them. Well, what are these said specific or common angles? Well, if I take a poll right now from all the students watching this video, what are the most common angles that you come across when you study part of triangles? I know that the answers would be 60 degree would take the first prize. Second would be 30 degrees, 45, 90, and well, there's another one that you may not say, that is 0 degrees. I'll show you why said angles are specific or common and what the values for these angles, that is the trigonometric ratios of these angles are, and how we can calculate them very easily. Coming to the first, we'll calculate the trigonometric ratios of the angle 45 degrees. Let's say that the triangle given on a board is a right triangle with one angle as 45 degree. Of the top of your heads, what will angle A be? Very good, angle A would also be 45 degrees. If you don't know how we got that, just apply the angle sum property, keeping in mind that this angle at the vertex B is a right angle. But hold on, by the properties of triangles, we know that if two angles are equal, two sides are equal as well. That would be the side opposite to this angle and the side opposite to this angle. What does that make this triangle? Take a second and give me your best guesses. The correct answer is that triangle ABC is an isosceles triangle. If you don't know what an isosceles triangle is, please go and watch the video Triangles part 1 and 2 and then come back to this video to understand better. Well, moving on. So now side AB is equal to the side BC. Let's just say they are of some length A. So what would be the length of the hypotenuse AC? Again, by applying Pythagoras, we get h square is equal to p square plus b squared. The edge being nothing but AC. So AC squared is equal to the perpendicular, that is A, and the base A. Both are A, so A square plus A square, which would give us 2A square. Now applying the root to this AC, we get that the hypotenuse is nothing but root 2 times A. Now as we know the length of all the three sides, let's go about calculating the trigonometric ratios for our angle 45. The first is the sine. We know that the sine is the perpendicular divided by the hypotenuse. So the perpendicular being A and the hypotenuse being root 2A. A and A get cancelled out. We get that the sine of 45 degrees is 1 by root 2. So the cosine of 45 would be the base divided by the hypotenuse, which is also A by root 2A, which we get 1 by root 2. So very important thing to remember here is for the angle 45 degrees, the sine and the cosine are of equivalent values. Moving on, the tangent of 45 degrees can either be given by dividing the perpendicular by the base or dividing the value of the sine by the cos. In any case, the value we will get will be 1. If you divide 1 by root 2 by 1 by root 2, we'll also get the same answer. To calculate the remaining three trigonometric ratios, we'll just apply the relations between the different trigonometric ratios that we learned earlier. So cosecant is the reciprocal of sine. As sine is 1 by root 2, we'll get that cosecant is root 2 by 1 or simply root 2. The secant in the same way is the reciprocal of cosine. So 1 by root 2 will be reciprocal as root 2 by 1, which is also root 2. Now we can get cot 45 by reciprocaling the value of tan. So if tan 45 is 1, cot 45 would be equal to 1 by 1 or just simply 1. So these are the different trigonometric ratios for the angle 45. Moving on to the next common angle. Well, 30 and 60 always go hand in hand when it comes to right triangles. So the triangle ABC, let's say, is an equilateral triangle, and we drop a perpendicular or an angle bisector from A to D. By the properties of equilateral triangle, we know that if we bisect this angle, this line would also be perpendicular to said side BC. Let's name this joining point as D. So now this angle is 30 degree, and we know that in equilateral the angle at vertex is 60. And as this is perpendicular this angle would be 90 degrees. Now, if you can look at the angle ABD and the angle ACD, they are congruent. Do you know how? If you don't, please go and watch the video Triangles Part 2 to understand congruency better. Now, as triangle ABD and ACD are congruent, this would mean that BD and CD are equal, and so are these two angles. Now, let's just see for the triangle ABD. Again, let's just try to calculate the values of the three different sides of said triangle. As I told you, ABC is an equilateral, so all the sides will be equal. Now, if BD is equal to DC, which means that BD and DC are half of the side BC. So BD would be A by 2. So what would be the value of this side AD? Again, applying by applying Pythagoras theorem, we'll get that h square is equal to p square plus b square, which is the hypotenuse is of length A. So A squared is equal to the perpendicular, which we don't know, let's just leave it like that, and the base is A by 2, so that becomes A square by 4. Now P square would be equal to A square minus A square by 4. We will get 3A square divided by 4. So the perpendicular would be root 3 by 2. Now, to calculate the T ratios for this angle here, 60. We'll calculate it for 60 first. Now, we know that the sine is the perpendicular divided by the base. Let's just write the value of the perpendicular here. So now, sorry for my mistake, the sine can be given by dividing the perpendicular by the hypotenuse, which would be root 3 by 2a divided by a. The a and a get cancelled out. So sine of 60 is root 3 by 2. The cosine of 60 degrees can be given by dividing the base by the hypotenuse. The base is nothing but a by 2, which when I divide by a, I get 1 by 2. Now to calculate the tan of 60, I can either divide the perpendicular by the base or simply divide the sine by the cos, which we get root 3 by 2 divided by 1 by 2, we get root 3. The next is the cosecant, which would be the reciprocal of sine, so it will be 2 by root 3. The secant would be the reciprocal of cos, which would be 2. And the cot of 60 can be given by reciprocaling the value of tan, which would give us 1 by root 3. Now, to calculate the values of the T ratios for angle 30. If we consider this as the reference angle, this would be the perpendicular and this would be the hypotenuse. So sine can be given by a by 2 divided by a, which would give us 1 by 2. The cos of 30 can be given by dividing the base by the hypotenuse, which would give us root 3 by 2. Now, the tan of 30 degrees would be the perpendicular divided by the base. Should be equal to 1 by root 3. Now to calculate the cosecant, by reciprocaling the sine we get that cosecant is equal to 2. In the same way, to calculate the secant, we just reciprocal the value of cos and we get 2 by root 3. And last but not the least, the value of cotangent would be the reciprocal of tangent. So 1 by root 3 would get reciprocaled as root 3. So these are the values of the trigonometric ratios for the angles 30 and 60 degrees. The next common angle would be the 0 degree. But before we begin, have you ever seen a triangle with a 0 degree angle? Well, here it requires a little bit of imagination. Let's say we have a right triangle ABC, the right angle being at the vertex B. If we start increasing the value of angle C, or in simpler terms we start decreasing the value of the length of BC without affecting the length of the other sides, we see that C gets increased and simultaneously A gets decreased. In the end, we'll reach to a point where C and B are almost coinciding and the value of angle A is approximately 0. Not exactly 0, but approximately 0. Let's just say angle A is equal to 0 degrees. Now as you can see in this case, AB becomes roughly equal to AC. Going back to our original triangle, AC was the hypotenuse, BC was the perpendicular, and AB was the base. In this new triangle, we can see that the base is almost good as the hypotenuse and the perpendicular is almost good as 0. So to calculate the value of the sine of 0 degree, we just divide the perpendicular by the hypotenuse, that is 0 by AC, which will give us 0. Now, the value of cos would be the base divided by the hypotenuse. As you can see, the base AB and the hypotenuse AC are almost same. So when we do that division, we get 1. So the value of cos theta would, cos 0 in this case, would be 1. Now the tangent can be given by dividing the perpendicular by the base. The perpendicular, as we said, is almost good as 0 and the base is AB. So we write 0 by AB, which gives us 0 again. Now we'll calculate the value of the other three t ratios just by reciprocaling these three. The cosecant of 0 degree would be the reciprocal of 0, that is 0. Sorry for my mistake, it would be 1 divided by 0, which is not defined. Now, coming to secant. The secant is the reciprocal of the cosine. So 1 divided by 1 would be equal to 1. And in the same way, the cotangent of 0 degree is the reciprocal of tan. So 1 divided by 0 will again be not defined. So these are the t ratio values for the angle 0 degree. Moving on to the next common angle, which is 90 degrees. So this next angle is 90 degrees. But again, have you seen a right triangle that has two right angles? It won't form much of a triangle, will it? Well, again, we'll just do a little bit of imagination. We use the same process, but in this, we concentrate on the angle C. For angle C, this would be the perpendicular, this would be the base, and the hypotenuse is as it is. As we start increasing the value of C, there will come a point where C and B will almost coincide. So the value of both these angles will be 90 and 90, as angle A is equal to roughly 0. So now we know that the base is almost 0, the perpendicular and the hypotenuse are roughly of equal length. So the sine of 90 can be given by the perpendicular divided by the hypotenuse, which is AB divided by AC. And as you can clearly see, AB and AC are almost equal. So sine 90 would be equal to 1. The cosine, however, is the base divided by the hypotenuse. The base being almost good as 0, we write down 0 by AC, which would give us 0. Coming to the tangent is the sine divided by the cosine of that particular angle, which is 1 divided by 0, which is not defined. Moving on to the cosecant, we can calculate the cosecant by reciprocaling the value of sine. Now, sine is 1, so the reciprocal of 1 will also be 1. The value of secant 90 can be arrived at by reciprocaling the value of the cosine, that is 0 divided by 1. Sorry for my mistake again. It will be 1 divided by 0, which is also not defined. and we come to the value of cot 90. As this was 1 by 0, we take the reciprocal, which is 0 by 1, so cot 90 is equal to 0. So these are some of the t ratios for some common or specific angles. Well, you can say to me that, sir, there are 6 ratios for each of 5 angles, which is 30 values that we are supposed to remember by the top of our head. Well, that's not so. There's a very easy way to immediately calculate all the t ratios for all the said common or specific angles, namely 0 degrees, 30, 45, 60 and 90 degrees. How do we do that, you ask me? Well, we have a very easy and fun trick which, if you follow with me, you will be able to calculate the t ratios of said angles anytime, anywhere, and that's my guarantee. Well, as I told you, to calculate the t ratios for said specific or common angles, draw a table that looks something like this. If we are calculating for a reference angle, let's say A, the value of A goes from here to here, and these are the trigonometric ratios. To calculate the trigonometric ratio values, the first trick is to calculate the sine. How do we do that? Well, the first step would be to write 0, 1, 2, 3 and 4 along this line. The next step is to divide this by 4. All these values we just divide by 4. And then we place a square root over all of them. Now, by evaluating this, 0 divided by 4 would be 0 and the square root of 0 is also 0. 1 by 4, when we square root that, we get 1 by 2. Now this would cancel out as 1 by 2, and when we square root that, we get 1 by root 2. Now taking out the root of 3 by 4, we get root 3 by 2, and 4 by 4 is 1 and the square root of 1 is also 1. So we calculated the value of sine for all these common or specific angles. How do we calculate all the rest? Follow my lead. Now the value that you wrote for sine 90, just write it down in cos 0, and so on and so forth. So the sine of 60 goes to the cos of 30. This would remain same. The sine of 30 goes for the cos of 60, and the sine of 0 goes for the cosine of 90 degrees. Now that we have calculated these two, calculating the rest would be quite simple, as we already learned how they are related to each other. The tan of any angle can be given by dividing the sine by the cos of said angle. 0 divided by 1 would be equal to 0. 1 by 2 divided by root 3 by 2, we get 1 by root 3. 1 by root 2 by 1 by root 2, we get 1. Now root 3 by 2 divided by 1 by 2, we will get root 3. And for the last, the tangent of 90 is 1 by 0, which is not defined. Now we are supposed to calculate the value of cosecant, which we know is the reciprocal of sine. So the sine of 0 is 0. So the reciprocal would be 1 by 0, which is not defined. Now the reciprocal of 1 by 2 will be 2. The reciprocal of 1 by root 2 would be root 2. The reciprocal of root 3 by 2 is 2 by root 3. And the reciprocal of 1 would again be 1. In the same way, to calculate the values of the secant of these different angles, we just take the reciprocals of their cos values. So the reciprocal of 1 is 1. The reciprocal of root 3 by 2 is 2 by root 3. The reciprocal of 45 or 1 by root 2 is root 2. Again, the reciprocal of 1 by 2 is 2, and the reciprocal of 0 is not defined. And for the last, that is the cotangent, we again take the reciprocals of the tangents. The reciprocal of 0 is not defined. The reciprocal of 1 by root 3 is root 3. The reciprocal of 1 is 1. The reciprocal of root 3 is 1 by root 3, and the reciprocal of this would be equal to 0. Wasn't that a fun way? And didn't we get a lot of the values that took us a long time to calculate? Well, when you look from an exam point of view, if you are not able to remember these values, which I am very sure many of you will not be able to, just draw this table in a rough space so that you can remember the values and use them as and when required. So now that we have learned the values of the different t ratios of said common and specific angles, how do we apply that? Let's say we have a right triangle in which this angle is 30 degrees and we are given this hypotenuse as 15 centimeters. And it says that we are supposed to find all the sides of this triangle. Easier said than done, right? Well, so the sine of 30 degrees we know as it is 1 by 2. So, and by formula, sine would be the perpendicular divided by the hypotenuse, which means that we don't know the perpendicular, so just write P. P by 15 should be equal to 1 by 2, or P will be equal to 15 by 2, which we get as 7.5. We could apply some Pythagoras theorem to calculate the value of the base, but it's not required. Let's just have a little bit more fun. So, now we know that the cos of 30 is given by the base divided by the hypotenuse, which we know will be equal to root 3 by 2. So now that we do not know the base, we just write that as b. And b by 15 should be equal to root 3 by 2, which we will get as b is equal to root 3 into 7.5, as 15 by 2 is 7.5. So this side will roughly be equal to 12.995, or we can round that off as 13 centimeters. So this is how we are supposed to apply the values of not only these common or specific angles, but the t ratios of all the vast angles that are out there, and to calculate the sides of the triangle or vice versa. Let us move on. So now that we have covered the topic of the common and specific angles and the t ratios, let us move on to exercise 8.2 in your NCERT textbooks. The first problem requires us to calculate this value, that is sine 60 into cos 30 plus sine 30 into cos 60. Just a note that this is the first part of the first problem. Well, coming back to it. From the table, if we remember, sine 60 was root 3 by 2 and cos 60 was 1 by 2, and sine of 30 was 1 by 2 and the cos of 30 was root 3 by 2. So now, to calculate a value, we just substitute sine 60, which is root 3 by 2, into cos of 30, which is also root 3 by 2, and sum that up with sine of 30, which is 1 by 2, into cos of 60, which is also 1 by 2. We get root 3 into root 3, 3 by 4 plus 1 by 4. As the denominators are same, we can calculate as 4 by 4, which is equal to 1. The second part of this question says 2 times the tan square of 45 plus the cos squared of 30 degrees minus the sine squared of 60. Again, let's just write down the arbitrary values. Tan of 45 is equal to 1. So the tan squared of 45 will also be equal to 1. The cos of 30 is given by root 3 by 2. So the cos squared of 30 would be 3 by 4. And in the same way, sine of 60 is equal to 3 by 4. I'm so sorry. It is equal to root 3 by 2. So the sine squared of 60 would be equal to 3 by 4. Now, just substituting these values, we get that 2 times into tan squared of 45, which is 1, plus the cos squared of 30, which is 3 by 4, minus sine squared of 60, which is also 3 by 4. As these both are common, we just cancel that out and we get that the answer is equal to 2. In the next one, we are supposed to calculate cos 45 divided by the secant of 30 plus the cosecant of 30. Just to remember the values a bit, if you can remember, cos 45 was equal to 1 by root 2. Now the secant of 30 was equal to 2 by root 3 and the cosecant of 30 was equal to 2. So now just substituting them in this equation, we get 1 by root 2 divided by 2 by root 3 plus 2. So if we cross multiply this, we get this would be our answer. Moving on to the next problem. It says sin 30 plus tan 45 minus the cosecant of 60 divided by the secant of 30 plus cosine of 60 plus the cotangent of 45. So let's just write down the values individually. The sine of 30 would be equal to 1 by 2. The tan of 45 is equal to 1. The cosecant of 60 is equal to 2 by root 3. Secant of 30 is also equal to 2 by root 3. The cos of 60 is equal to 1 by 2 and the cotangent of 45 is equal to 1. Just substituting all these values in said equation, we get 1 by 2 plus 1 minus 2 by root 3 divided by 2 by root 3 plus 1 by 2 plus 1. Taking the LCM as 2 root 3 here and 2 root 3 down here as well. So if we multiply this by root 3, we get root 3 plus 2 root 3 minus 4. And down here we will get 4 plus root 3 plus 2 root 3. So we can cancel this out. We get 3 root 3 minus 4 by 3 root 3 plus 4. Just to rationalize the denominator, if we expand this also, we'll get the answer equal to which will give us 43 minus 24 root 3 by 11. This will be our final answer, but you could also leave it just till here. This wouldn't be wrong as well. So moving on to the next problem, we have this huge equation here. It says 5 times the cos squared of 60 plus 4 times the secant squared of 30 minus tan squared of 45 divided by sin squared 30 plus cos squared 30. So again, let's just write down the individual values. Cos 60 would be equal to 1 by 2. So cos squared 60 would be equal to 1 by 4. Now, secant 30 is equal to 2 by root 3. So secant squared 30 would be equal to 4 by 3. So tan 45 is equal to 1. So tan squared 45 will also be equal to 1. And the last two, that is sin 30 is equal to 1 by 2 So the sine squared of 30 will be equal to 1 by 4. And the last but not the least, the cos of 30 is equal to root 3 by 2. So the cos squared of 30 will be equal to 3 by 4. Now substituting all these values into the equation. 5 into 1 by 4 plus 4 into 4 by 3 minus 1 divided by the sine squared of 30 plus the cos squared of 30. The LCM down here is 4 and we add both, we get 4, which will give us 1. To calculate up here, we have the LCM of 12. So 5 into 3 would be 15 plus 4 into 4 is 16, and multiplying that by another 4, we get 64 minus 12, which gives us 67 by 12, or we can write that down as 57 by 12. This is our answer. The next question is to choose the correct option and justify your choice. The justification required here is just to show our calculation. Well, it says 2 times of tan 30 divided by 1 plus tan squared 30. Let's just calculate what that comes to. So tan 30, as we know, is 1 by root 3. And multiplying that by 2, we get 2 by root 3. That is the value of 2 times of tan 30. Now, tan squared 30 would give us the square of this, which is 1 by 3. Now, just to put it in this equation, we get 2 by root 3 divided by 1 plus 1 by 3, which will give us 2 by root 3 divided by 4 by 3. And if we cross multiply this, we get the value root 3 by 2. Out of all the options present on the board, we know that root 3 by 2 is the value of sine 60. So this will be our answer. The next question says 1 minus tan square 45 by 1 plus tan squared 45. Let's calculate what that comes to. So tan 45 is equal to 1. So tan squared 45 will also be equal to 1, as the square of 1 is always 1. Now, to apply it in the equation, 1 minus tan squared of 45 by 1 plus tan squared of 45. We get 0 by 2, which is equal to 0. And out of all the values on the board, this is the only value that matches our answer. So we tick this. The next question says sine 2a is equal to 2 times of sine a is only true when a is equal to. Let's just see. So, sine of 2 times of a. This would mean that whatever be the value of a, we first multiply that by 2, then calculate the sine of that particular angle, is equal to 2 times of sine of the angle a itself. That is 2 multiplied by the value of the sine of angle a. Let's start with 0. So sine of 2, 0, that is 0, will be equal to 2 times of sine 0. As the sine of 0 is 0 and the sine of 0 is also 0, this is equal to itself. If we try and calculate the value of any other of them, we know that sine of 30 is 1 by 2. And 2a would be 60, which is root 3 by 2. And twice of 1 by 2 will be 1, and root 3 by 2 is not equal to 1. So we know that 30 isn't the answer. The same goes for 45 and 60. So it's only true when a is equal to 0 degrees. In the next, we have 2 tan 30 by 1 minus tan squared 30. Let's try and solve this again. Now tan 30 was 1 by root 3, and twice of tan 30 will be 2 by root 3, right? And remembering by the one that was quite similar to this from which we just solved, we got that tan square 30 is 1 by 3. Applying it to the equation, we get 2 by root 3 by 1 minus 1 by 3, which will give us 2 by root 3 by 2 by 3. We cancel this, then we get 3 by root 3, which we can write as root 3. And we know that root 3 is equal to the tangent of 60 degrees. And it does not match with any of the others. So tan 60 is our correct answer. Moving on to the next problem. It says that if tan a plus b is equal to root 3 and tan a minus b is 1 by root 3, considering that a and b both are acute angles, that is, they are greater than 0 but less than or equal to 90, and a is greater than b, find the value of a and b. Let's just write down what we have. We know that the tangent of 60 is equal to root 3. This would imply that a plus b is equal to 60 degrees. And we know that the tangent of 30 degrees is equal to 1 by root 3, which means that a minus b would be equal to 30 degrees. Now, solving this by simultaneous linear equation, if we just add the second equation, cancel out b and we get twice of a is equal to 90 degrees, which means that a is equal to 45. And as a plus b is equal to 60, this means that b would be equal to 60 minus 45, which is 15 degrees. So the answer is that a is equal to 45 degrees and b is equal to 15 degrees. This is how we solve this problem. The next is a true and false type question. Let's go through them one by one. So sin a plus b is equal to sin a plus sin b. Let's take some arbitrary values for a and b. Now, if we calculate sine of 30, we know it's 1 by 2. And the sine of 60 is root 3 by 2. And on adding these both, we get 1 plus root 3 by 2, as the LCMs are, the denominators are same. And if we calculate the sine of a plus b, that is 30 plus 60, which is 90, we get 1. And we can clearly see that these two values are not the same. So this statement would be false. Coming to the next one, or the next two I should say, or even the next three, if you can just go back to the trigonometric table of the common or specific angles that we drew, it will give you enough explanation for all three. If you see the values of sine theta from 0 to 90, we see that it goes from 0 all the way up till 1, which means that when theta increases, the sine theta also increases. So we can say that this statement is true. However, the next statement says that the value of cos theta increases as theta increases. We know that the cos of 0 is equal to 1 and the cos of 90 is equal to 0, which shows that when we move from 0 to 90 degrees, as the angle measurement increases, the value of the cosecant goes, the value of the cosine goes down. So it does not increase, in fact it decreases. Next, it says that sin theta is equal to cos theta for all values of theta. But from that table that we drew, we know that sine and cos are only equal when the angle theta is 45 degrees. For all the other angles, they are always some different values. So this statement would also be false. Now cot A is not defined for A is equal to 0 degree. This last one I am going to leave on you guys to see the table and answer it for yourselves. So students, sad to say this, but we have come to the end of our lesson. But don't you worry, the second part of this very interesting topic, trigonometry, is on its way and is going to come very soon. So stay tuned to our channel. And if you have some doubts or queries that you would like to be answered, comment down below and let me know. Till then, see you, goodbye and namaste.